Dear students, this session is about Boolean algebra and logic gates. Specifically, this about logic gates. So, this presentation is an introductory presentation regarding logic gates. This will give you information regarding logic gates and its basic operations. We will see the logic symbol, operation, Boolean expression and truth table of each logic gates. Before going into details of logic gates, dear students, you should understand that we have circuits known as digital circuits. The question is, what are digital circuits? Answer: these are the circuits handling digital signals. Okay, then what are signals? These are informations and are of two types: analog signals and digital signals. And by the way, here while we talk about signals, electronic signals are specifically intended to use, and they are either current or voltages. So we are talking about digital circuits. They are dealing with digital signals, and these signals are either currents or voltages. Signals can be of two types, analog and digital. Let's see the details of analog and digital signals. Actually, what's the difference? My dears, you can see a graph here, analog versus digital. From the graph of analog signal, what is your idea? Analog signals whose values are varying continuously. For example, air temperature, sound loudness, light intensity. The values are varying continuously. Then the next diagram is for digital signals. What's the difference? The values are discrete. These dots are the values. They are discrete. They are not continuous. Coming to the important point of a digital signal, it has two states. Important: digital signal has two states, either high or low. Usually, high is represented by using binary number 1 and low by the binary number 0. You all know the number system where binary number has only two values, 0 and 1. This binary number is used for representing a digital signal. And there are two types of circuits: analog circuit and digital circuit. Analog circuit work with analog signals like continuous variation of signals, but digital circuits handle with digital signals that having two stable states, either high state or low state. Hope you understand digital circuit and analog circuit, digital signal and analog signal. Okay, let's move further. So coming to logic gates. Now we have the background to understand logic gates. Actually, logic gates are the basic building block of any digital circuit. Now you know what is a digital circuit. It handles digital signals. The logic gates are the basic building blocks of any digital circuit. So these logic gates have one or more than one input, but they have only one output. And the relationship between the input and output of a logic gate is based on certain logic. Certain logic is there between the input and output of a logic gate. And these logics are represented by some logic operations of product, sum, inversion, etc. Based on this logic operations, logic gates are named as, you all are familiar with these terminology, and, or, not, nor, NAND, XOR, XNOR, gates, etc. So of these many logic gates, the basic gates are AND, OR and NOT gates. And the other two gates, NOR and NAND, are known as universal gates. So my dears, logic gates are the basic building blocks of any digital circuit, and a logic gate will have one or more input, but it has only one output. And the basic gates and or not X are the basic gates, and the other two are the universal gates. And from this slide onwards, we are going to see each gate, its logical expression, operation, Boolean equation, truth table and symbol. This is very important. You have to learn thoroughly. Let's see what is an AND gate. AND gate uses logical product of inputs. So it is a logical product circuit. It takes two inputs and output is it will have one output, and its output will be 1 if both the inputs are 1 and 0 otherwise. The logical expression of AND is a dot. That is the AND operator. That is, you have to put a dot in between to show AND operation. For example, if output Y is equal to A and B, instead of AND, you will put a dot symbol. And you will read this equation as Y equals A and B, not A dot B. So A, B are the inputs and the output is Y. The logical symbol you can see, and the truth table. If the two inputs are 0, output is 0. If any of the input is 0, 0, 1, it will become 0, 1, 0, it is 0. And if and only if both the inputs are 1, the output will be 1. So this is a logical product circuit. Then coming to OR gate. OR gate is a logical sum circuit. That is, it will have an output of 1 if either or both the inputs are 1. And the output will be 0 if both the inputs are 0. The logical expression of OR is plus sign. We can show the logical equation as Y equals A or B. We can use this plus symbol to notate the OR operation. How will we read this equation? Y equals A or B. This OR is standing for logical sum operation. Symbol is shown here. Dears, A and B are the inputs and Y is the output. So one more point that I add, that is A, B. The order of this input is important. When we write y equals A or B, A should be the first input and B should be the second input. If this is B or A, how will we write here? Instead of A, we write B, and instead of B, we will write A. The order of input is important. That order I mean to show the symbol. Okay, in this symbol, A is first and B is second. So we will write this equation as A or B. And the truth table 0, 0 will be 0, 0, 1, 1, 1, 0, 1 and 1, 1 leads to 1. So this is a logical sum circuit. Coming to the NOT gate. Then what is its operation? You all know that NOT gate is an inverter circuit where the operation is inverse, taking inversion of the input. If the input is 1, output is 0. If output is 0, input is 1, vice versa. So what does that mean? NOT operation can be represented with a bar symbol. That is, you can see here, example y equals A bar. How will we read it? Y equals not A. Okay. Can see the logic symbol, a triangle with a bubble. This bubble indicates the inversion. In any logical circuit where bubble you see, you think that is an inversion is happening. Here, what is the peculiarity of OR NOT gate comparing to AND and OR? Yes, this gate has only one input and there is only one output. All the other gates can have one or more inputs, but NOT gate will always have one input. Then coming to the truth table, if A is input and Y is output, if A is 0, output will become 1, and if A is 1, output is equal to 0. So logical inversion is happening. So coming to NOR gate. Actually, NOR gate is a combination of two gates. A NOT gate followed by an OR gate. That means OR gate is followed by a NOT gate. First an OR gate is there, it is followed by a NOT gate. So NOR is standing for NOT OR. So T is changed. So mixing together NOR. It is an OR gate followed by a NOT gate. So that is, you can see the symbol. Actually this is OR and it is followed by NOT is represented by this bubble. If the inputs are A and B, the logical expression will be A or B inversion. So that is, this is the logical symbol of a NOR gate. That means the inversion of OR circuit. Okay. So what about the truth table for the OR gate? You just remember 1 will be the output if any of the input is 1. But here the inversion happens. When 0, 0 for OR output is 0. But for NOR it is the inversion. That is, it is 1. For all the other cases, for the case of OR gate, it will be 1. But in the case of NOR gate, it will be 0. So that is, here you can see in the symbol there is an OR gate with a small circle on the output, and this small circle will indicate the inversion process. That is OR followed by a NOT gate, inversion. Okay. So remember the truth table. It is the inversion of, the output is inversion of OR gate's output. Then coming to the NAND gate. What is NAND gate? It is combination of NOT and AND gate. That is an AND gate followed by a NOT gate. That is the NAND gate. NAND gate symbol is AB bar. What about the truth table of NAND gate? It will be the inversion of AND gate. That is AND gate, we know that the output will be 1 for only one case, that is 1 1 is equal to 1. But here you can see that this is, I think there is a mistake. NAND is 0 0 will become 0, that will be 1. 1 0 will become 0, that becomes 1. And 1 0 is 1, correct? And 1 1 becomes 0. This is the mistake that I corrected. You got, my dears? That is the inversion of AND. 0 0 will be 1. 0 1, the input 0 0 gives 1. 0 1 gives 1. 1 0 gives 1. And for AND gate we have 1 1 gives 1, but here it is 0. So this is AND gate followed by a NOT gate, and the small bubble indicates the inversion process. So this NAND and NOR gates are termed as universal gates. Why? Because NAND and NOR gates can be used to generate all the other gates like AND gate, OR gate and NOT gate. That's why they are termed as universal gates. They are used to generate all the other gates. How it is possible? It is possible by combining 1, 2 or 3 NAND or NOR gates. Let's think about it. Okay, this question is important. Why NAND and NOR gates are termed as universal gates? How can you combine NAND or NOR gates to give outputs of AND, OR and NOT gates? Okay, please think about it. And coming to the other gates, next is exclusive OR gate. Exclusive OR gate is termed as XOR gate, and the symbol is an encircled plus is the symbol, and the logical symbol, you just see the logic symbol. Okay, A, B are the inputs. Output is A XOR B. We will read this as Y equals A XOR B. What is the condition of inputs and outputs? 0 0 leads 0, 0 1 leads 1, 1 0 leads 1, 1 1 leads 0. You can see that for XOR gate, the circuit have high output either any of the inputs is 1. When it is becoming both 1, it will be 0. So any of the input should be 1, that is leading to the high output. So this is XOR gate. So next gate is XNOR gate. So what is XNOR gate? Exclusive NOR gate. You just look on to the logic symbol. XOR gate that we discussed on the last slide, followed with a bubble. So the inputs, you just look, A, B the inputs, output will be A exclusive OR bar. So that is, the truth table will be inversion of XOR gate. We have for XOR gate, you please remember my dears, for XOR gate we have 1 at 0 1, 1 0 condition. For XNOR gate, that both these two conditions become 0, other two will become 1. Hope that you are understanding this. So I hope that you all got a basic awareness on base building blocks of a digital circuits known as logic gates. Thank you, my dears. If you have any comments, please add on to the forum. Thank you.